Hi everyone, this is lesson 7-4 and we are going to be walking through this lesson together. The title is Applying Properties of Similar Triangles, and I want to start by you looking at the picture in your book on page 481 showing depth. In this flat painting we have the look of great depth extending into the distance. Let's read about that. Artists use mathematical techniques to make two-dimensional paintings appear three-dimensional. The invention of perspective was based on the observation that faraway objects look smaller and closer objects look larger. Mathematical theorems like the triangle proportionality theorem are important in making perspective drawings. So let's look at that theorem, the triangle proportionality theorem. It says if a line parallel to a side of a triangle, here's the line that's parallel to the side of a triangle. If it intersects the other two sides, which you can see it does, it intersects the left side and the right side, then it divides those sides proportionally. That means that we are going to have a relationship where AE is to EB as AF is to FC. Now, one thing I want to point out to you that's going to be important as we move forward in your homework, but especially on the test, is that you don't confuse this with the times that we are comparing two triangles that look like this, where we have the top triangle and then we have the large triangle. So we have the small triangle and the large triangle. That is different because then we're having to compare the sides of the triangles. So we compare the small side to the large side. This is different. This theorem is telling us that, trying to get more light on here, that when the triangle intersects the sides of the triangle, it divides those sides proportionally. So again, AE is going to have a relationship with EB that's the same as the relationship between AF and FC. Y'all, I'm going to turn on the light, and I think that'll help you be able to see better, so give me just a sec. Okay, I don't know that it helped a lot, actually. Let me try moving my book. There we go. All right, so that's all we're going to do on that page. You don't need to worry about the construction, but let's look at an example on the top of the next page, page 482. And I'll try to get you back in the light. There we go. The light is coming through my dining room windows, and that's kind of messing up the appearance in the book. All right, we want to find the length of a segment, and here is our diagram. So it says find CY. It's given that XY is parallel to BC. So AX is to XB as AY is to YC. So you can see I have written a proportion for this. 9 is to 4 as 10 is to X. And as you're used to doing, we simply cross multiply and solve for X. And in this case, X is 4.44, which is the length of CY. Okay, let's look at our check it out. Number 1, find PN. Well, we're going to treat this the same way. Let me see how I set it up originally. Okay, we're going to say that the relationship of LP is to PN as MQ is to QN. So I have 3 over PN is equal to 2 over 5. So this is to this as this is to this. And then we're going to cross multiply. We're going to have 15 equals 2 PN, and PN equals 7.5. So PN right here is 7.5. All right, let's see. Moving on, our next theorem, 7-4-2, is just the converse of what we just learned. So this is the converse of the triangle proportionality theorem, and in this case, it says if a line divides two sides of a triangle proportionally, then it's parallel to the third side. So it's just the opposite of what we learned a while ago. If a line, being EF, right across the middle, if it divides two sides of a triangle proportionally, then it means that it is parallel to the third side of the triangle. So let's look at an example having to do with that. This time we're going to verify that MN and KL are in fact parallel by proving that 42 is to 21 in the same way that 30 is to 15, or that those are proportional. So let's try it. Jm over mk is 42 over 21, and that reduces to 2. Jn over nl is 30 over 15, which also reduces to 2. So these two sides are proportional, which means that mn is in fact parallel to kl. All right, let's look at the check it out for that, and then I will stop and start a new video. Okay, the check it out says AC is equal to 36. Here, I'm going to show you the diagram. I think that might be the best thing. AC is equal to 36. BC is equal to 27. Again, verify that DE is parallel to AB. So we simply are going to write a proportion. But what they gave us in this problem was only this, 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 and this. So I had to actually find out what DA was by saying 36 minus 20, and that's 16. And then I had to say 27, the whole side, minus the 15 that I was given, and get the 12. Now I can see if the sides are proportional by saying 20 over 16, or I could say 16 over 20. Either way, I have to do it the same both times. So I'm going to say 20 over 16 and see what that reduces to, and then I'm going to say 15 over 12 and see what that reduces to. And as you can see, they both reduce to 5/4. All right, so that shows us that AB is in fact parallel to DE. All right, I'm going to stop there, plug in my phone, and then start back and finish this lesson.